Linear programming. Oh yeah, you probably want the paper, son. Linear programming. Used a lot in, well, I'll be honest with you, computers do most of this work, but we can do some simple ones by hand. Used a lot in production, supply demand, that kind of thing. A lot of times, creating the inequalities is what's the hardest part. Because once you get that, it's basically what you did for yesterday. Once you get the inequalities in the max-min function. It's just you got to get there. And so it can be complicated. But that's why we talk about it. And, I'll be around tomorrow morning if you have any questions. We can do 2 examples, 1 example, whatever you want. Really doesn't matter to me. What I do is I give you some steps, and here they are. The first thing you're going to want to do is define some variables. Some people always stick with X and Y because they don't want to do anything different. And that's fine with me. It doesn't bother me at all if you want to stick with X and Y. But some try and make the variables mean something to them in the problem. And so you need to decide what you want to do. And then I'll show you what other people do is they kind of do both. And that's fine. So then we have to write the constraint, which is normally just the inequalities. That's all that means. Then we have to graph it and find those vertices. We have to write the max-min function. Now these are from the book, this order. I don't do them in that order. Okay? Because I think there's an easier way to do that. And which of these have we done? Have we really defined variables? No. They just kind of have been given to us, haven't they? They've been X and Y, so we didn't really have to define anything. Did we have to write the inequalities? Not yet. Did we have to graph them? Yeah. Did we have to write the expression for max-min? Well, we didn't have to write it. They kind of gave that to us, right? But did we have to substitute the values? Yeah. And did we have to figure out which one was the biggest and smallest? Yeah, so I do agree. A lot of this we have done except for the writing of the stuff. But we've done everything else. So what I like to do is obviously you take a look at the problem. Is that the first one you have? Yeah? Okay. So I got a telephone company. I can make 2 types of cordless phones. They're deluxe and standard. Each deluxe telephone gets me $9 profit. Okay? And each standard phone is $6 profit. But the problem is I have 2 completely separate machines that I have to send them through. Okay, maybe one gets the circuit boards together, maybe one puts the shell on or something like that. I got 2 different machines. Are used to make both styles, so I need to send them both styles through both machines. And each deluxe requires 3 hours of machine A time and 1 hour of machine B. So it takes maybe 3 hours to get the circuit board in the deluxe and only 1 hour to put the rest of it together. Where standard takes 2 hours to get the circuit board together, but then 2 hours to put the casing on or something like that. An employee has an idea that frees 12 hours of machine A time and 8 hours of machine B time. Determine the mix of telephones that can be made during the free time to generate the maximum amount of profit. Let's face it, doesn't that sound like what companies are going to do? They're going to want to maximize profit. Okay. And just by looking at all that information, you just, 3. Yeah, I don't think you're just going to come up. There's no guess and check on this one. All right. So step 1 is to define your variables. Some people would say something, and you can make up your mind. It's up to you. A lot of people will use other letters, and that's an S. It'd be deluxe. Wow, it helps if you put the D down, though. So we'll say number of deluxe. And here we'll put number of standard. Now, how did I know that? Well, I knew that because I looked at the question. It says determine the mix of telephones that can be made during the free time to generate the most. So that's what they want to know. Now, what some people do is they say, all right, so I know my variables, and they just make a little note that this is going to be X and that's going to be Y so they can graph. Is that okay to do that? Yeah, nothing wrong with that, right? And so it really doesn't matter in the end, but that's what some people do. Or they just go ahead and say this is X and Y. Believe it or not, I do not follow. I don't do step 2 second. I don't even do step 3 next. I actually do step 4 next. And there's a reason for that. Step 4 says to do what? Write the max-min function is basically what it says, correct? And what is it that I want to maximize? According to this question, what should I maximize? Profit. So what you should do is go find anything in here that talks anything about profit. And you go find it. All right, so we go along. Do you agree that that is the only sentence in this entire paragraph that talks about profit? Are there any other sentences that talk anything about money? Okay. So we know that each deluxe, which is D, gives me $9 profit. So what if I had 10 deluxe? How much profit are we talking about? And what if I knew there were 10 standard? How much money are we talking about? So you just multiplied those numbers, didn't you? So to max and min function, all you have to do, what was it, 9 for D? 9 for each deluxe. And add how much for each standard? 6. That is your f of ds function. Okay. Now, why do I do that first? I could have done that at step 4, couldn't I? That would have been okay to do that there. So why do I do it so early? Any ideas? Why would I do it right away? Well, you see that stuff highlighted in green? Am I going to use it again? No, I'm done. That stuff highlighted in green you can cross off. You're done using it. You don't need it anymore. It's gone. So now you won't try and use that information in the other ones. It's gone. Whenever I start step 2, I look for any minimums. Do I have to make 3 deluxe? Do I have to make at least 7 standard? Does it say that anywhere? No. But there's a understood minimum. If it's not stated, we know the minimum is 0. Right? Can you make a -2 number of telephones? No. So we know that at least 2 of your inequalities, you should always know them. Now it all depends. Now, if they said I had to make a minimum of 5, then you would have said greater than or equal to 5. If they would have said I can't make any more than 12, you would have said it had to be less than or equal to 12. Right? But it didn't say that. There are 2 more inequalities. And I think once we get them, we're well on our way to solving this one. So once I find those 2, I normally look for anything else I know the total of. Do you agree this is talking about machine A and B, and it's talking about how many hours I could be on those machines, correct? Talking about A and B, and then down here, do you agree that we have now 12 hours of machine A? That's the total amount of time extra we're going to have on machine A. And then on B, we have 8 hours of extra time. That's the total number of hours. So what if I went and I made... The deluxe requires 3 hours on machine A. Could I possibly make 3 of them then in the time requirements? I could, right? Could I make 20 of them? No. So we know that I have to take this times however many I make, and I can't get above 12. Do you agree with that? So we know a lot about hours, don't we? So what we're going to do is we're actually going to make inequalities regarding the hours. We know one of them for, let's do a different color, machine A. What do we know about machine A? It can only go up to 12 hours, right? So we're going to have something written here, and then it has to be less than or equal to 12, because I can't go over 12 hours, right? And we'll color code things for machine B. Where is that? Well, that has to be So have I basically used that sentence that I have underlined in green and blue? Have I used that information? It's in my inequality. I've used it. Let's scribble it off. Because it's just narrowing down where I have to look. And that last sentence is just a question. First sentence is just general information. And basically so is the third sentence. So each deluxe telephone requires 3 hours of machine A. So for every deluxe, I need 3, correct? Hours. Now, this is the hard part for some people. I just used where's the other machine A information? That's the hard part. Yes. Exactly. It's kind of right below that, isn't it? It's right here is the machine A information. So we're going to go 2 for each what? 2 for each standard. Does that look like an inequality that all deals with hours? Hours, hours, hours. Correct? So can you do the same thing for machine B? You sure can. So each deluxe, done. Each standard machine A, done. So what number, we know there's some D's and some S's, right? We're going to add them together. What times D for machine B? Because here's D, right? Deluxe. Meaning how many hours? 1. Do you have to write the 1? No, but you might want to make sure that you did that. And how much of each of the other one? 2 of machine B. Everybody see that? That right there is the hardest part of these problems. Without a doubt. These 2 in red inequalities, not so bad. These 2 over here, the green and the blue, these can be difficult. But I know that all of you can do it. So we've done step 1, we've done step 2, we've even done step 4. Now we must do step 3. I'm going to write these over here because I don't know that I remember them. Now, based on how quickly some of you did this yesterday, this shouldn't take very long. Because now we're doing what you did yesterday. Everybody ready? So we'll say this was D, right? And this is S. That's how we said it earlier. X and Y, right? That's how we set it up. And so I just have to write them again. Well, I think 2 of the easy ones to start with are, we know that has to be greater than or equal to 0, right? So we know we're going to end up in the first quadrant somewhere, right? Maybe that's D equals 0 and S equals 0, throwing us up in the first quadrant, right? Again, if you like X and Y, that's fine. So how do you suggest we go about graphing that one right there? Yeah, pretend it's equals and go from there, right? And so if you pretend it's equals, what's probably an easy way of getting some points? Is an XY table okay? Sure. In fact, if you look closely at those numbers, I think it's pretty simple to try and do that particular table, right? The numbers work out fairly nice. They don't always. Sometimes you got to get a different number, but these work out really nice. Now, I called it an XY table. We kind of could call it a D and S table, right? So you put 0 in for D. What do you get for S? 6? I don't know why I made that one red, but there you go. If you put 0 in for S, D is, let me know if I'm going too fast, but you guys were graphing these quick yesterday, so. You notice, have I done any shading yet? No. Normally when I'm given a linear programming problem, I kind of wait till the end, and then I shade. Again, XY, or perhaps if you want to call it DS, whatever you want to do. Can we do this one the same way? Yeah? pretty nice numbers. So if I put 0 in for D, I get 4. 0 in for S, I get 8. And I'll let you kind of get caught up. And then I'm going to point out to you that we really have 3 different places that could be this polygon that we're talking about. And we have to decide which one is it. You want your graphs to be pretty accurate because we got to find these vertices too. So there's one kind of out in the middle there that could be questionable. We're doing pretty good though. Looks like you're mostly caught up. So basically we have spot 1, 2, or 3 that could be the polygon, correct? Could be. But we already know that the first 2 inequalities got me to the first quadrant. So now we can just check some points on these other lines. And what's probably the easiest point to check on those 2 other lines? Just try 0, 0. So if I try 0, 0, what, this was less than or equal to, right? So you put 0 in there, well, that's 0, 0, less than or equal to 12. So I have to shade below that line, correct? So shading below that line, that's this one, means I go that way. So now which one have I eliminated? It can't possibly be 2, right? But it still could be 1, well, it could be 3, could be 1 and 3 combined, who knows? But our guess is, well, actually it's either 1 or 3. Our guess is it's probably 3, but so we put 0, 0 in here to test it out. And is that true? Yes, it is. So in other words, when we shade, we have to shade below that other line as well. And so here is our polygon. And it's quadrilateral. And that's about all we know about it, is that it's a quadrilateral. And seeing we had 4 inequalities, that makes sense. Make them nice and big for us here so we can see them. I'd say that last one I did is the one in question. But I think the other ones are pretty straightforward, right? 0, 0 is the one on the bottom left here. There's a vertex. How about the one kind of on top left there is 0, 1, 2, 3, 4, right? How about bottom right is 1, 2, 3, 4, 0. And what do we think that other one is? It looks like 2, 3, right? Now how can we check to make sure it was 2, 3? Well, do you agree it's basically where that line and that line are hitting each other, correct? And isn't that basically these two? So shouldn't 2, 3, if this is a system of equations, 2, 3 should make both of those true. But they should make them both equals. Does it? If I put 2, 3 in, does it work? 2 there makes it a 6, plus 6 is 12. That's believable. How about here? 2 and 3 doesn't make the bottom one. It does. So it is actually 2, 3. So we did a good job of graphing. So those are our vertices. I'm going to have to write them down over here so that I don't lose them. And now we're almost done. We did the max-min function already, so we're nice. We don't have to do that yet. And step 5 says basically to substitute them in then. F of 0, 0 is an easy one. 0, 0. Well, that's an easy one you get. You know, how about 0, 4? We'll go down to this bottom one. So 0 in for D, 4 in for S. 24. 4, 0. 2, 3. If you ever have this happen in a linear programming problem, I would like you to select which one you believe makes more sense. What I mean, if this ever happens, if there's a tie. Obviously, the least is making no more phones with that amount of time, and we increase profit by nothing, according to this simulation. Okay? We just have our people sit there for those hours and do nothing. Or our other two options, I think you'll both see that this neither maximizes nor minimizes, correct? But this one here says to make 4 what? Deluxe and 0 standard. This one says 2 deluxe and 3, and they both are going to increase profit the same amount. So I want you at this point to pick either one, but have a reason for it. Okay? That's completely up to you. I think both of these could have good reasons for them being correct. Okay? Just keep in mind we had 4 inequalities in ours. In a really good simulation of this, there'd probably be 30 inequalities to take into consideration, because this has nothing to do with supply and demand. Okay? So we did a very simple one compared to what computers are doing. So again, you'd have to pick one, give me a good reason. So then you'd write that down here. Maybe you chose 4, 0. So 4 deluxe and 0 standard because. Okay? Or 2 deluxe and 3 standard because. And come up with the reason.